We are going to discuss about the two architectural styles, that is distributed and layered architecture, uh, uh, how it is implemented on Apache Spark and their impact on the quality factors, scalability, reliability, and interoperability. So first of all, we have to understand what is Apache Spark and why it is needed. So Apache Spark is a high-performance enterprise-grade data processing framework, and how it achieved this high-performance gain, uh, basically through in-memory processing. Uh, it achieved this objective. So rather than dealing with the traditional file systems like Hadoop does with HDFS, it keeps data in memory when during the processing. So with the architectural styles we are going to discuss next, Spark accommodates various features. So why we need another framework like Apache Spark, because there are several other frameworks also before that. So over traditional systems like Hadoop MapReduce, it provides better performance and better scalability, reliability, and also interoperability. So and, if we want to understand Apache Spark and why these quality factors are quality attributes are necessary. First, we have to understand what is big data, because Apache Spark is all about big data processing. So we have to understand the characteristics of big data. So basically, we can summarize big data processing characteristics into 5 ways. So there we have 5 V's stands for volume, variety, and velocity, and the veracity and the value of data. So we have to deal with large volume of data, which grows fast or rapidly. And on the other hand, we have to deal with different sort of data. That means some of data are unstructured, like text files and files, and some of them may be semi-structured, like XML or JSON, or some of them are structured, that we can, as we can see in databases and other systems. So apart from that, we have to consider the velocity of the data that we have been receiving when we consider a big data processing framework. So we may get a high volume of data at high speed. For an example, if it's a click stream from a website, it may be a social media feed, or likewise we may collect data in high speed, and we have to process them uh, in at the same level. So again, and at the next point is veracity, that is the accuracy and trustworthiness of the data that we collect, or that we produce at the end as the end result of the big data processing. So ultimately the value, but so meaningful insights for decision making in the case, uh, uh, the actually the data that we process, or the results or statistics or insights that we produce should be accurate, meaningful, and also have some sort of a business value at the end. So when addressing these characteristics, we can we shall observe that the quality attributes that we are going to discuss are key factors, because without these things, the 5 V's will be completely violated, or in this case, we will not be able to achieve or reach the expected quality level in that in these 5 V's. So basically, these quality attributes that we are going to discuss are basically scalability and the reliability and the interoperability. Yes. Uh, we are going to start with the distributed architecture. So in this case, uh, uh, after going through this, how this is implemented in Apache Spark, we will be able to identify how these quality attributes were achieved with the particular architectural style we identified. So Apache Spark is both physically and logically distributed. In that case, if we shall go through uh, from the beginning of this workflow. Basically, the application is the external entity that may be maybe an ERP system, maybe an website that request that submits the data processing request. So then we have the Apache Spark driver, and the driver decides how this request is going to fulfill. Then the next level is the cluster manager. Cluster manager allocates the required resources to perform the particular task or the computing job. So then behind that, we have worker nodes. Worker nodes are basically physical or virtual machines which has some sort of computing capacity or CPU capacity and also memory uh, and disk capacity attached to it. So these are sort of physical and virtual machines basically. And within that we have executors. Executors are the basic unit of computing which carries out the actual task. So if we uh, by depending on the worker node's capabilities or the capacity, there may be multiple executors within the same node, or it may be a single executor. And we shall see uh, with the support of the cluster manager, we can add more worker nodes in this architecture without with less effort, or without putting huge effort. We can scale this by adding more worker nodes, and in, in that case, the architecture of Apache Spark is horizontally scalable. And on the other hand, uh, we can add more resources to the worker nodes as well. In that case, we can add more memory, more CPU power, and we can increase the number of executors exist in a particular worker node. So on the other hand, RDD is the fundamental logical unit that stores data in Apache Spark. And RDD, which means resilient distributed data sets, shall be partitioned into multiple partitions, basically, multiple sections, and distribute across the worker nodes. And also we can, to improve the reliability, we can replicate this data, and also we can cache to improve the performance as well. So if we move on to the next, we can summarize the distributed architecture along with the quality factors, scalability, and reliability. Basically, we can the scalability, we can achieve high level of scalability with the horizontal and vertical scaling capacity, scaling capability of the Apache Spark, and also by adding the resilient distributed data set or the RDD into the system, we can have the higher level of reliability. And apart from that, as you can see in the distributed architecture diagram previously, we can, in a case of point of at the point of failure, we can, yeah, it can be the Apache Spark can easily recovered from that point of failure. So, and we move on to the layered architecture. Uh, in layered architecture, we can see the the Spark ecosystem is separated into multiple layers. So clearly, it is the concerns of the each layer is clearly separated. So Apache Spark is developed with Scala, and also it's on JVM, Java Virtual Machine. So, but however, it because of its it separates its internal behavior, internal functionality through APIs. Uh, it it makes itself highly interoperable. So if we start from the top layer, that's the application layer. That Apache Spark provides a set of application layer components. That means support from all different languages like Scala, Python, Java. These uh, Apache Spark has built-in support for these languages, and also third-party language supports also available like for .NET and kind of other ecosystems as well. So and the next level is API layer, and the API layer consists of different features of the Apache Spark framework, like Spark Streaming, Spark SQL, graphics processing, and machine learning and stuff as well. So in that case, the external applications can easily utilize these features and fulfill their computing needs with Apache Spark easily. So, and the next level is the Apache Core Engine, and which handles the internal logic, internal functionalities like drivers, executors, and task schedulers. And the bottom level, we have the resource manager. This is basically the cluster manager itself. So cluster manager in that level, we can use the standalone cluster manager that exists in the Apache Apache Spark itself. So and in addition to that, we can use Yarn, Mesos, so even Kubernetes uh, for better performance in that case than the standalone cluster manager of Apache Spark. The bottom level is physical or hardware layer and worker nodes and storage. So we can see these internal complexities are hidden below the bottom layers, and uh, with the upper layers like API and application layers, uh, the Apache Spark framework became more interoperable with the external systems, and also with the resource manager level at the resource manager level, and with the other features like libraries, connectors that incorporate with the Apache Spark, we can use external file systems and resources as well. So, that is how the layered architecture and the interoperability works together. So the data present requests may come from different or the vast variety of applications. or different ecosystems like maybe a Python application, maybe .NET or something like that. But Apache Spark is still capable of interacting with them. And also we can easily replace the internal components. For an example, we can switch from a standalone cluster, uh, sorry, it's cluster standalone cluster manager to a yarn in that case. Or we can use existing enterprise resources like existing data lakes that may be on AWS S3 or maybe different data warehousing system or different file systems like HDFS or uh, basically log files, flat files. So this kind of interoperability is can be achieved due to the modularized layered architecture pattern followed by the Apache Spark. So in addition to that, we shall see uh, the quality attributes that we have discussed have further enhanced with different by adding different functionalities or different features to the Apache Spark system. So Apache Spark introduced the third-party cluster manager support, that is yarn users over the standalone cluster manager later, so it increased its performance in scalability. And also recently it has introduced Kubernetes as well. And to improve the reliability, uh, it has yes, and you can see the reliability, RDD, the resilient distributed data sets are the key components that handles the data, handles the reliability for data in Apache Spark. And also it provides checkpoint recovery modes as well. That means another feature added later. That means partially processed data can stored. So in the case of failure, it should not have to process the entire thing from scratch. Instead, it can roll back to the previous checkpoint and continue the processing. And also it has added multiple driver supports. Driver is the main access point to the Apache cluster. So that's where it receives jobs from external, processing jobs from external applications. So to avoid, to handle failures at a driver, it introduced support for multiple drivers. So in a case of a failure at one driver, another one will take over the job. So then the next part is the interoperability, how it's enhanced the interoperability. It has added connectors and data source supports. That means it can utilize any data source from databases to live streams to file systems like AWS S3. And also it has the built-in support for multiple languages and also for others. There are third-party language support additions. And also for cluster management and automation, it provides now REST APIs, so it's sort of can be managed easily and optimize and improve in such cases. So and also it supports Parquet and Avro kind of data formats, which are commonly used data formats in industry. So it can communicate with external systems using these data formats. And, next we are going to look at how these key attributes are going to affect the other attributes in the systems. So this table summarizes that. So basically scalability impact the performance attribute positively because Spark scales both horizontally and vertically. It improves the performance and also increase the maintainability as well. And likewise, reliability is has a positive impact on both performance and the availability. And interoperability also increase the usability of this framework. And when considering the security, because the Spark supports a vast variety of external system accessing or dealing with, it can deal with vast variety of external systems, and since it has many point of contacts, then we should have to consider the security aspect critically in that case. And so to maintain the expected level of security, then we might need to put additional effort due to the highly operability nature of this framework. So we shall see the software architecture of the Apache Spark has evolved throughout the time. First, it started with standalone cluster management systems, but later it introduced support for other existing cluster managers like Yarn or Mises. So that improved the scalability of the system. And later it again introduces Spark SQL and structured APIs. And so basically it gave the Apache Spark framework to use the familiar SQL queries, to use familiar SQL queries when dealing with data sets in it. So it enhanced or it improved the interoperability of the system. And also Kubernetes supports also introduced later. So again, this improved both reliability and scalability, because now it supports container orchestrations built in. So, and we can compare Apache Spark with the similar systems widely used in industry. So, Apache Hadoop is one of the oldest and matured framework exist or implemented before Apache Spark. But however, it is a file-based system and highly scalable and easily scalable, because it's deal with file systems or the disks basically and when it comes to in-memory scaling up it's less complex than scaling a system that is more rely on memory than a file system. So Hadoop is easily scalable than Apache Spark, but it is Apache Spark also is high performs well in scaling as well. So Apache Storm is basically focused on real-time processing, and it scales really well in the particular context. So Apache Spark stands in between both Hadoop and Apache Storm. So it has both batch and real-time processing capabilities while providing the highly reliable and interoperable uh, environment for the external applications. So, as a summary, we can understand that Apache Spark is Apache Spark provides better scaling for vast data volumes and processing workloads, and also it is fault tolerance and data integrity. It ensures the data integrity and it's basically dependable. So in that case, we can achieve our objectives of having a 5 years when we consider the 5 years of big data processing. So at the same time, it is highly interoperable. It's compatible with different data sources, vast data sources and formats, and also it's can interact with different external systems. Mm. Thank you very much.